Hey class, how we doing? So as you know, I decided to cancel our on-ground class today, and the reason why I decided to do that is because the roads are not clear, the roads are dangerous. So I mean, there's no point in going to campus. Well, I know that most of you live nearby, but there are some students and also myself that uh, does not live nearby, right? So why take the chances? Um, so yeah, the this is module one, part B, right? And well, I would say that most of what we're going to discuss here today, well, not most, but at least some portion of what we're going to discuss here today has been covered in class already, okay? But there are some stuff that we need to understand and we need to discuss. So, again, we already covered this, but let's just briefly recap. What is applied computer science? Well, first of all, you have to understand that there is a difference between computer science and applied computer science, okay? So computer science is a large field with a rich history, right? And obviously, I strongly recommend that you read the computer science Wikipedia article carefully, obviously, but computer science is a broader area. In information technology, right? It's more focused on the science of how computers work. So let's say that it involves a lot of theories, a lot of algorithms, a lot of concepts, the creation of how things work. And then, so as you can see, algorithms and data structures are central to computer science. Now, the fundamental concern of computer science is determining what can and what cannot be automated, whereas applied computer science focuses on applying theory in practice. So all those theories, concepts, algorithms, solutions that are created by computer scientists, well, the applied computer scientist is more focused on identifying what is available in order to solve a specific problem, right? So focused on identifying what is available. So the goal is not necessarily to create new things, new concepts, new algorithms, new ideas. It's to identify what is out there that can be used to resolve a problem, for example, right? Um, so one thing that you must keep in mind and that you must be asking yourself during the entire course is how does it apply to your field? How does computer science and applied computer science, obviously, right? Because we're talking about how to apply in your field. So we're talking about applied computer science. Well, and obviously, as you must have noticed already, right? Technology follows exponential growth. So it's if you compare with most of the other areas, if not all other areas, right? Technology is growing much more and much faster than all other areas. This means that the rate of change is always accelerating. And that is why, and probably you heard this before, but people tend to say that in information technology, if you learn something today, most likely this is not going to be applicable or it's not going to have so much use in 5 years from now, okay? And I actually know that by experience. So just to give you an example, when I moved from Brazil to the United States to do my PhD, I kind of stopped doing the consulting. I stopped with the consulting projects that I had. And I did my PhD. I finalized my PhD in 3 years. So the knowledge that I had when I left Brazil, and then when I concluded my PhD, and I was like, okay, now I need to keep up. I need to understand what the new trends are and it was completely different. It's almost like, as far as the applications that I used before coming to the US, they're not usable. They're not, there's no use to them anymore. Obviously, the concepts, they stay because everything is based on concepts, theories, right? Mathematics. But the applications, they changed. So, for example, the internet became commercially available around 1995. iPhone was introduced in 2007. ChatGPT was launched in 2022. So, observe how fast things are evolving in IT, right? If you take any other areas, you're going to see that the evolution, the growth of that specific field has a lifespan of many, many decades, in many situations, even hundreds of years, right? Now, oops. There we go. Okay. Now, so I strongly recommend that you watch this video on the history of computer science. This is a LinkedIn training video. For some reason, I just tried it today. This is January 16, 2025, and LinkedIn was something wrong there. I was not able to access not only this video, but all the LinkedIn training platform seemed to be down. Okay, maybe it's back already. But anyways, I strongly recommend that you watch this video. I also strongly recommend that you study the history of computer science. As you can see here, this is an article in Wikipedia. But we are going to briefly do a basic overview about the evolution of computer science, right? So again, observe how fast it evolved. If we go back to the 1950s, that's when we have the development of the first commercial computers, such as the UNIVAC and IBM 701, right? We also had the creation of programming languages like Fortran and COBOL. Now, again, we're talking about commercial computers, right? We're not talking about those mainframes like you see in the movies or in textbooks, a mainframe that would require the storage capacity was an entire building or a very large room. No, we're talking about commercial computers, right? And then in the 1960s, we had the invention of the integrated circuit, which reduced the size of commercial computers a lot, right? That's actually one of the main ideas of integrated circuits. And that resulted with the introduction of the first high-level programming languages such as BASIC, right? The integrated circuit allowed the evolution of programming languages as well because of their not only the size but also their computation capacity. Then in the 1970s, we had the development of microprocessors. This was huge, right? So if you search for the image of a microprocessor, you're going to see how small they are. There are microprocessors that are even smaller than your pinky toe. So imagine a small computer. So for example, nowadays, people talk a lot about Arduino, right? Raspberry Pi. These are basically they are computers, embedded computers, but still they are computers. And everything there is done, all the processing capacity, the computational capacity is executed by a microprocessor. So imagine a computer that is the size of your pinky toe. And then we had the emergence of artificial intelligence research. This was not a product at the time, but people started to study this. Now, at the time, and I believe that I mentioned this already in class, right? It wasn't called artificial intelligence. Basically, it wasn't even artificial intelligence as the way how we know artificial intelligence nowadays. It was artificial neural networks, but still a huge evolution in the history of information technology and computer science. And then in the 80s, we had the widespread adoption of personal computers. Now we're talking about personal computers, right? Computers that you can have at home. Obviously, this is something that was only possible because of the creation, the design, and deployment of the Macintosh computers and also the Windows operating systems, right? Now we have an interface, right, a graphical user interface that anybody allows anybody, not only engineers, right, computer engineers, but also, well, basically anybody could use a computer now because you have that graphical user interface as this one that you see right now, and the use of a cursor controlled by the mouse hardware, right? Then in the 90s, that's when I would say that this is the greatest breakthrough in computer science. That's when the internet became widely available, right? And also, obviously, this was allowed by the development of client-server architecture. This is an architecture where you have a system providing a service, and we as clients can leverage that service. So, for example, when you open your browser and you visit a web page, well, that's because you have a web server that is hosting that web page, and you are the client in this communication. So you, the client, request that web page. The web server that is providing that service will send you the web page, the files that compose the web page, so that you can visualize that web page on your in your browser. Okay. And then in the 2000, we had the emergence of mobile devices and smartphones. And I believe that I mentioned this in class, maybe last class or the class before. Students, especially students, right? You guys in your age, there is a chance that you don't even have a laptop. Well, I know that you have a laptop because you need it for your studies, but there are some people under their 25 years old that they don't have a laptop computer, they don't have a desktop computer, but they do have a smartphone. Now, the opposite nowadays is just something that you're not going to see. You won't see someone that has a laptop computer but does not have a smartphone, right? And with that, the dissemination of these mobile devices, well, now everybody basically is connected. Some people have more than one mobile device, and then we have the Internet of Things, IoT, right? So basically your fridge is connected to the internet, your TV, so you name it. All electronic devices nowadays, they are communication capable, right? Well, with that, we have the growth of data available in the public network. So we have a growing importance of big data, machine learning, and the cloud. Right. So that's the evolution of computer science. Now, the reason why I bring that up is because it's important that you understand this evolution so that you also understand how your field is, what are the benefits of computer science, specifically applied computer science, to your field, right? Again, something that we discussed already. So that you have a greater idea of the importance of the topics that we are going to discuss in class. So, for example, data analytics, programming, networking and security. If you visit our website, the Applied Computer Science Program website. So there is an entire program called Applied Computer Science. If you visit that website, there you go. You're going to see that there are courses, an entire semester, an entire specific course for a specific topic that we are going to cover in class, right? So for example, networking, that's one. Digital security, that's another one. Big data applications and business analytics. Introduction to programming, advanced programming, right? So survey of programming languages, web application development. All these topics are associated with those topics that we are going to study. So if we go back to our topics, and they are right here. If we go back to these topics here, you're going to see that there is at least one course in the Applied Computer Science program that corresponds to a topic here. Network and security, for example, there are more than 2 courses. Programming and software development, there are more than 3 courses. So what I want you to understand is, obviously, each of these topics here, they're not just topics, they are an entire field. But the goal here in our course in CMPS 101 is not to deeply cover these fields. It's to understand the topics and how these topics are applicable to your own field of study, okay? So that's ultimately, that is our goal. Also, if you are interested, I would recommend that you check out the Bureau of Labor Statistics. Obviously, here you can see information about all occupations, right? But this link here, the link that I included in the PDF file in these slides, is a link to jobs that are specific, occupations specific in computer and information technology, okay? So I would recommend that you do that so that you understand some of the occupations that we have in computer science and information technology. You also have a medium pay here. Maybe when you look at this, you might be attracted and you might decide to follow this career path, okay? But just out of curiosity, and you can click here so that you can gather more information about what that specific professional does, okay? So now the assignment that you have for part B is you need to submit a PDF containing the answer to the questions below, okay? So you need to identify 3 applications of computer science that are most useful to you, okay? So you are supposed to use the material provided in the slides to look for examples, explain how each application applies to you or your future job. Make sure to include at least one example for your professional career. Identify any applied computer science program courses that could help you learn more. So that link that I provided to you, that lists the course that we have in our applied computer science program. Include additional information on how you could learn more about it and discuss whether learning about these fields could help you with job prospects, okay? So pretty simple assignment, total of 1 single page. I would say that this should take no more than 20 minutes to maybe 30 minutes to complete it, okay? So again, that's all that we had for this class. I really appreciate you guys watching it, and now you should work on the assignment. If you have any questions, please shoot me an email, or you can send me a message through Element. Okay? Thank you very much. Bye-bye.